In this video, I'm gonna show you how I finally finished my real-life Wizard's Chess project. Let's get started. Before I begin explaining, you should probably start from the beginning and watch the trailer for this series if you haven't already. So first of all, here is a circuit. I'm gonna show you how I put everything together, but if you want to know how it's all connected, come back here. I started by taking my Arduino Mega and removing all the pins so I could later solder all the connections. Then I took the HC06 Bluetooth module and soldered it to a pre-drilled PCB. I soldered the Arduino Mega to the Bluetooth module and cut the PCB to the right size. Be careful when cutting circuit boards because you don't want to inhale the dust particles, so make sure to do it outside. The system will of course need to be able to calibrate on its own. So I connected two small buttons to the Arduino for the X and Y calibration. Now this part was really annoying, but I needed to connect 4 RGB LEDs to the Arduino, 2 in parallel for black side and 2 for white. Then I connected a switch between the DC jack negative and all the LEDs negative pins. To have the least wires possible going to the Arduino, I connected the 2 positive and the 2 negative wires from the servos together so only 4 instead of 6 were left. After connecting the servos to the Arduino, I connected the DC jack and X stepper motor. I then connected the Y stepper motor and put a potentiometer between the DC jack and Arduino. Then I also put one between the DC jack and stepper motors. This is not necessary, but it gives more control in case the stepper motors overheat. Now it's time to use some epoxy and glue all the electronics to the board. I used some tape to keep all the wires together and show which ones we're gonna need to move and cause the most difficulties. Then I also printed some brackets, is that what they're called? Anyway, I printed these things and glued them against the wood to keep all the wires out of the way of the moving parts. I had already attached the X calibration button, but now it was time for the Y button. Unfortunately, the way it was assembled, I couldn't glue it anywhere. So I printed a new small part so I could glue the button to that. I wanted to be able to see when the Bluetooth module was connected from the outside of the case. So I connected a LED to the positive of the Bluetooth module LED and the negative of the button. I printed this small part which the switch, DC jack and red LED all fit perfectly into. The reason I did this is because I know that when I cut holes in the wood with equipment that I have, it won't look pretty, but with this part I can just cover that up. And then last for the exterior, I glued the red LEDs, DC jack and switch to the 3D print, and then glued the 3D print to the wood. I took away the rotation servo and finally printed this small part, which is the perfect height and in which one of my neodymium magnets fit perfectly into. Then I glued it like you can see here and put the top back on the build. So the company that engraved these parts for me said they could not only engrave but also just print. So I let them print the chessboard itself as well. But instead of printing it on the wood as they said, they printed it on some acrylic and then glued that on the wood, which of course totally messed up my measurements and made it too thick for the electromagnetic field to travel through. So then I ordered that part again without any printing, printed the illustrations on some papers myself and cut them out. Then I glued it to the board and let it dry. I like building stuff, but I've been focusing on this project for more than a year now, and I haven't been able to do much apart from editing and building projects. Anyway, I hope you liked the video. If you did, like and consider subscribing, I'd really appreciate it.